Hello colleagues, critics, and viewers. My name is Andrei Turovsky, I work in the GIS department of the Risk Company, and now I will present to your attention an organizational and technical solution to optimize the web application development workflow. This presentation has been prepared for a wide range of viewers, including managers, architects, and developers, so I apologize in advance if at first I will describe things that are too simple and obvious for you. The presentation is simultaneously in Russian and English, so that it is easier for you to navigate. Where it is reasonable, the text of the Russian version is highlighted with a special background. The presentation lasts about 30 minutes. You can skip the uninteresting part for you and go to the desired one by the timing that you see on the screen. Part 1. In this part, we will consider typical life situations, the problems arising from them, and their obvious solutions. Imagine that we are conducting several projects. I want to stipulate in advance that I will be referring specifically to web projects, because the solution I am developing is focused specifically on the web, although these problems and situations are of a general nature. So we have two projects, Alpha and Omega. They are built on different databases, their architecture is not identical, the tasks that they solve differ, however, both projects have common features. There are components that perform the same functions, but they are designed a little differently and have some minor differences specific to each project. In the Alpha project, the login form is blue. The Omega project has a red login form. The map component is used both there and there, but with slight differences. The tabular data editor is also different because the data structures themselves are different. However, this was not always the case. The Alpha project appeared much earlier. Its start was relatively successful, the prototype solved the tasks, although it was not ready in its final form. Its development continued and it was not thoroughly tested. Later we started the Omega project, which seemed similar to us, and we expected that its implementation would take much less time. To do this, we decided to copy the existing functionality. We took the login form and transferred it to the Omega project, changing the colors. Similarly, we planned to proceed further with other similar components. At first, everything went as intended. Later in the Alpha project, we decided to add new functionality for entering the system. It was not in demand in the Omega project, but we also developed this project and added other useful features. In the course of working with the Omega project, we discovered a bug, and although we realized that this bug was most likely present in the Alpha project, there was little time, and we fixed it only in the version for the Omega project. Projects were led by different developers. In the Omega project, Peter changed the map. He did not document the changes, and the developers of the Alpha project did not understand how this change works and why. Thus, after some time, two previously identical components began to live an independent life, and now it has become difficult to transfer useful functions between projects and monitor errors. To avoid problems, it was proposed to make more universal solutions. This proposal was initially met with approval. However, the first solution to this problem that came to mind in the future turned out to be rather laborious and not optimal, but we will learn about this a little later. In the meantime, we decided to make the login form universal. Therefore, we took into account the potential difference and put the ability to adapt to the component. Now the form is blue or red depending on the check. Similarly, we fixed other components. Now all the components of the Alpha project are made in blue, and the components of the Omega project in red. However, in the course of the development of projects, now it is necessary to make changes to all universal components. So, for example, when the customer asked to make the login form for the Alpha Blue project, we did it, but now to maintain uniformity, we need to fix all the universal components. Usually the components are interconnected, that is, if we select something in the editor, we would like to visualize the selected data on the map and vice versa. In the new Gamma project, we would like to take the editor from the Alpha project, and the map from the Omega project. Due to the fact that these components are interconnected, we are forced to take into account all possible combinations, which increases the amount of work so that it seems that universal components do not pay for themselves at all. At least, they do not give a large increase in speed compared to the traditional approach, to write again each time, because you have to write again in any case. Summarize. If you do not use universal components, we are faced with many problems. The amount of work grows disproportionately faster with an increase in the number of projects, despite the fact that we essentially repeat ourselves many times. To conduct several projects in parallel, we need additional human resources. Introducing new features and controlling bugs is becoming very complex. If the components are quite difficult to implement and written by a specific programmer, he alone can develop or fix them, which creates bottlenecks in planning time wastes. Any even very simple changes have to be done by the author. An attempt by another programmer to create his own version eventually leads to branching of the project. In the case when there is not enough time for testing and thorough thinking through, reusing the component does not bring significant benefits. At the same time, creating universal components and reusing code is difficult to capitalize on due to various obstacles. The lack of a clear understanding of what can be changed, a unified system and approach to the formation of interfaces, components, the logic of work, architecture, selected technologies, etc., does not allow us to effectively organize the work process. Therefore, the natural conclusion is that all of these parameters must be somehow limited and clearly described if we want to benefit from code reuse. In addition to issues related to code reuse, a developer's life is full of difficulties at almost every step. The system should operate in different environments, on the developer's computer, on the tester's computer, on the customer's computer. These conditions can vary greatly, which complicates the search for errors. Data structures can change and require migrations. Projects can branch. Even in the case when the changes between the branches are purely cosmetic, the presence of several branches slows down the work many times. The developer is forced to spend extra time on any context switching. Therefore, we conclude that in order to increase the development speed, it is necessary to come up with a way to speed up the procedures associated with branching, switching, deployment, updating, etc. Summarizing the findings. Reasonable restrictions must be introduced, a unified understanding of the formation of the interface is necessary, the interaction of components should be simplified, all routine operations for switching contexts should be automated. Part 2, in which we will choose reasonable restrictions, and also set a general outline of the architecture that will allow us to benefit from code reuse. We are trying to make the system flexible enough to cover the situations we have. The color scheme and language will most likely in one form or another change from project to project. Here, the language is meant not just a foreign language, but what text the interface elements are accompanied by. In different conditions, the elements look different. Sometimes it is appropriate to write in detail, sometimes there is little space and the text should be as short as possible. However, if necessary, we will support translation into a foreign language. But most importantly, we cannot deliver functionality to the customer that he did not ask for, because any functionality must be paid for. Therefore, we must give the customer exactly what he paid for, but no more. More on this point we will stop later. We limit ourselves to the choice of technology and the main library for the formation of the interface. In fact, this choice can be any, however, it has already been made. Everything selected is a large project with a huge community. In short and clear, all these are worthwhile things. You see an example interface based on Material UI. This does not mean that all of our interfaces will be just that. Material UI is a very flexible and customizable library. The picture shows only one of the possible options. World-famous companies use this library. Details can be obtained on the internet. As the main manager of the layout of the interface elements, we choose a self-written solution based on React Flex layout. A specific implementation is not as important as the main idea. The workspace is divided into panels and the user can flexibly customize it for themselves. This video demonstrates the idea of docking layout. The specific implementation will be slightly different, but the same principles are behind it. Visually and in terms of design, our version will have a number of improvements. In older solutions, the components were strongly connected, that is, they contained direct links to each other. Such code only works if a large number of assumptions are made. And in particular, we cannot remove the second component from the circuit or replace one map implementation with another. If we are talking about a multi-window web application, when the map and editor are displayed in different windows, such a connection is impossible. When creating rich user interfaces, the issue of working in more than one window is very acute. In order for us to conveniently reuse the components of the map and the editor, we need to break their connection. In the proposed embodiment, all universal components interact only with the core of the system, and do not contain links to each other. This enables the editor to work even if there is no map component at all. Or instead of one implementation of the card, we have another. The interaction is carried out by sending simple text messages. To make absolutely all components universal is unreasonable. Some components exist by themselves, but others contain logic, settings, communication with the database, etc. Therefore, it is reasonable to isolate not the component itself, but the task that it solves, and all the objects associated with this task. So we got to the concept of a plugin. To interact with the outside world through the system core, the plugin has inputs and outputs of various types. We distinguish 5 types of inputs and outputs. In the future they can be expanded, but at the moment they are enough to cover most current tasks. Data store represents a data source, for example, a relational database, GeoServer, or other third-party service. Data provider is a utility for processing, reading or writing, data from any data store. Layout panel is a user interface element. Context describes a certain configuration. Message is used to interact with the kernel and other plugins. The system core, in turn, has a number of services. Current plugin settings, connections, passwords, plugin versions, related resources, etc. are processed by the configuration manager based on the repository. The latter is also used to store intermediate calculations, data of large and small volumes, stored both locally on the client side and on the server side, in memory and in the kernel database. The panel layout manager is responsible for rendering the entire interface. The messaging service controls the interaction of the plugin. Translation of interface texts and data, possibly into a foreign language, is carried out by a translation service. For colors, layout, and other design differences, the design service and themes are responsible. Each plugin interacts with the outside world through only these services, the descriptions of which are clearly defined and will not change in the future. I present to you the Wortex system, which implements the architecture described above, and also contains additional features that accelerate and facilitate the development, testing, deployment, and support of web projects. Over time, projects are oversaturated with interface elements, which greatly complicates the development of new components. Wortex allows the developer to configure all the components for themselves and leave in the current project only those functions that he currently needs. For example, if we are developing a plugin for entering the system, we are unlikely to need map and tabular data components. This is done using the configuration server. All settings for connecting to databases and other services may differ on the developer's computer and on the customer's computer. Once the installation management server has registered the necessary configurations, it automatically switches between them, which saves time and makes the code more secure, because it now does not contain credentials, they are encrypted in the kernel database. The plugins installed at the customer can be turned off. For example, we provided a new version, but it turned out that it contains an error. We can disable the plugin of the new version and activate the old one using the activation server. For synchronization and updates, the update server is responsible. The project administrator can be both the customer and us. The administrator can configure the system at the request of the customer. This includes the translation of interface elements and data, translation administrator panel, control over the color palette and design, the choice of specific functionality if the developer has provided such an alternative, and some plugin has several versions. In addition to versions as an alternative, we distinguish between the build number, which is only growing. As errors are fixed, we automatically upload more recent builds to the customer's server. The administrator has the right to decide whether to upgrade assemblies to more recent ones. This is an important point. For example, if the data format changes in the new assembly, and we do not want to harm the current work of users. In case of errors, the administrator, as well as the developer, can choose a different configuration and roll back versions or remove experimental plugins from the project, for example, remove incomplete tools for demonstration to the authorities. In the above architecture, almost all independent logical units of previously developed and currently under development projects can act as a plugin. This ensures ease of reuse and saves time developing new solutions. Thank you all for your attention and for reaching the end. I will be glad to receive criticism and suggestions by email andret@risk.az or andre.turovsky@gmail.com.